Now, previously, when I've stood in front of you, I think the last 3 or 4 years, things were a little bit different. So I should first point those out. I used to work for the education office, the education department for a while, and not any longer. I've switched jobs. Now I work in the Human Spaceflight Directorate as a payload system engineer for Columbus, which is very nice for me. I enjoy it. It's great. But that's a slightly different context. So I'm here by the gracious invitation of the Education Office. I'm no longer working directly for them, but I'm still very involved in some education projects, particularly Genso, which I'm here to talk to you about today, where I'm still working as a system engineer. There's also another slight change. Previous years, I've had to apologize every time for the strange blank space after my name. But finally, I got round to passing that license. So thank you very much. So thank you for everyone that kept pushing me and saying, "Oi, why don't you hurry up and do that?" And special thanks to IFO. Where's IFO? For helping, yes, hi. For helping me with the Dutch translation of all the exam questions from past years. So this presentation is on the Global Educational Network for Satellite Operations, GENSO. And I'm presenting as a member of the system engineering team, along with Brian, who I'm sure you all know by now. So first, just a bit of a recap on what GENSO is all about. So the current situation is that you have a typical student space segment will be a CubeSat or something in low Earth orbit, probably sun-synchronous with the AX-25, usually using the amateur radio bands. But typically, each spacecraft will only have one ground station dedicated for its use at the university that built the spacecraft. And this ground station typically will be capable of communication on VHF or UHF. It will have a single rotator and a single computer controlling it. But the problem is with that at most latitudes where most of us live, apart from these crazy people in Greenland, we only see maybe 4 passes, 5 passes a day, depending upon the latitude. So maybe the ground station is used for 4 or 5 sets of 10 minutes a day, and the rest of the time it sits there doing not very much, really. That can be easily up to 97% of the time the ground station sits there completely idle, which is kind of strange because it's on the right, it has the right capabilities. It can talk on the right frequencies and the right protocols to listen to all of the other educational spacecraft that are passing overhead, not being spoken to because their ground stations are somewhere else. This seems like an awful waste. So a better approach, we decided, was if we could develop a system where all of these ground stations would automatically track each other's spacecraft and deliver the data to where it needs to be. They're all perfectly capable of doing so. They're spending most of their time doing nothing else anyway. If we can develop this system such that it respects the local mission and they have no change, they can do whatever they were doing anyway, but they all track each other's spacecraft and the data gets forwarded back to the mission operators, then we have a much nicer situation. And we can then potentially have radio amateurs involved also, and you Amsat members, and myself as an Amsat member now, enjoy, of course, tracking these spacecraft and retrieving data from them. This system will allow a lot more of that. And if we can involve radio amateurs, then we have a very large number of ground stations. We have a very, very large percentage of coverage. So rather than just 3% coverage or so while it comes over your own station, we can, with enough radio amateurs, we can easily cover North America and Europe for a start. And then if anybody wants to go somewhere strange to fill in gaps on the map, this is much appreciated. This gives you quite a few advantages. You get a big increase in mission return, and this we can see from the Delphi C3 presentations yesterday. These guys showed us a very nice map of everyone who has downloaded data for them, which was much appreciated, I'm sure. And the mission wouldn't be in such a good state if the radio amateur community hadn't helped to this extent. So that's a very good example of what can happen with just one mission. But remember that each of those contributors had to manually go and do stuff. They had to spend precious time to get this working, which of course everyone is willing to do. But imagine what you could do if it was automated to some extent, if it didn't take such a human involvement, and if it happened for every mission, rather than just for the Delphi guys that managed to set themselves up like that, which is very well done. We could have a very, very powerful situation. So our proposal is to develop a flexible global software standard, which allows all of the existing missions and the existing amateur radio ground stations to connect in a network and share each other's resources. So you may ask, who is doing this project? Well, we have the International Space Education Board, and this consists of the education departments of all the major space agencies: CNES, CSA, ESA, NASA, JAXA, or they have formed a board to have a coherent approach for education. And some responsibilities were assigned once the project was agreed, and ESA is taking the project management and coordination of the system engineering and supporting European participants to workshops, to Amsat Uk Colloquiums, and hosting some of the infrastructure, basically taking the lead in the project. And then NASA and JAXA are each supporting teams of students and potentially workshops once every 2 years for each of those agencies. So it's quite a nice international collaboration, which is obviously necessary for a global initiative such as this. So a bit more detail on the GENSO objectives. Primarily, we're after more access for educational spacecraft. We also want to be able to do that from stations that are not your own. We want to potentially even be able to have remote uplink sessions so that you can command your spacecraft from somewhere other than locally, which will help a lot with some missions, because quite often even if you're receiving telemetry via the radio amateur community, you want to command your spacecraft and you can't because it's not overhead. And we want to standardize the ground segment software. We want to standardize the hardware to some extent to give a reference optimal station. I'll talk about that a little bit more later, and so will John. And we can make recommendations from all of this for the space hardware as well, though they're just recommendations. We don't require any changes in the space segment for GENSO. But most importantly, and why we're here today talking about GENSO, is that this fosters very close collaboration with the radio amateur community. The project doesn't work without the radio amateur community. It's for the mutual benefit of radio amateurs and the education community. It's a bridge between the two. This picture is just an example of a university ground station, much like your stations at home. This one's in Luleå, Sweden. So I'd like to describe a little bit about what GENSO consists of. We have two software applications. The ground station server, which runs on every ground station in the network, and it abstracts the hardware from the control so that we can have a standardized set of commands that can control almost any radio amateur hardware. We simply need to have some drivers underneath. And this performs the passes of the spacecraft at the station. It rotates the antennas, it tunes the radio, and decodes the data, and then sends it off to where it needs to be. And where it needs to be is the mission control client, which runs for each mission. For each spacecraft, the controllers will run a mission control client. And this basically acts simply to retrieve the data from all of the ground station servers. I'll go into a little bit more detail on those in a moment. But central, we do have some infrastructure as well, the authentication server. And this acts to control who is, or to monitor who is online, who is offline, and the different attributes of each of the ground stations and the spacecraft missions. So it's basically acting as a distributor of information to keep the network current and consistent. I should talk there more, sorry. And then we have hardware definition, the reference ground station, which is being defined by a team from Amsat UK, of which I'm also a member now. And the idea of this reference ground station is to have, it's not a standard that everyone must follow, but it's an optimal solution at low cost to get the maximum return possible from Genso. So I've talked about this with you last year. So far I've given a very similar overview of the concept. But what have we done since then? Well, last November we had a very successful workshop in Aalborg University in Denmark. We used the Aalborg ground station, and there's a very nice ground station there. They have VHF, they have UHF, they have a Yaesu rotator, they have an ICOM 910, they now have a Cantronics 9612, and this station was used as a development station, as a test bed. But we had a large international collaboration, of course. We had the Austrian authentication server running to authenticate the Danish ground station servers and mission control clients. We were using American drivers. We were using some Japanese drivers. We were tracking spacecraft from all over the place, as you can see. And we had, after 4 or 5 very intense days in Denmark, we had a proof of concept demonstration. And the point of this was that we could basically lock the radio room, nobody inside. We could have webcams looking at the hardware. So a webcam looking at the roof and a webcam looking at the radio and rotator. And we could all sit in a meeting room with our arms folded going, oh look, spacecraft's coming up. That's nice. Up would come the spacecraft. The radios would tune, the antennas would track, we could hear the audio, the data was decoded, and later forwarded onto the MCC. But the important, you've all seen this before, but the important point about Genso is that it's doing all of that by itself, it's scheduling everything by itself, and you can just sit there and go, another spacecraft's coming up. And the configuration is changed to match that spacecraft, and this is tracked also. It actually gets to the point where you forget about it and you do something else, and you suddenly hear the rotator start moving. Oh, what's it tracking? Ah, that's nice. You lose track of what's coming up over the horizon next. It's that automated. So we were very happy with that. But I said I'd give you a little more detail on what these software applications are. So the ground station server. This runs on each radio amateur ground station. So let's start very simple. You have the station operator. Who can that be for Genso? Well, we're saying that it can be any radio amateur, anybody at all. Anyone with a station. It can be an educational mission. It can be students at a university. We're being open and flexible about this. And they have some ground station hardware, of course. What do they need to do when they get Genso? Well, they're going to have to configure it so that the software knows what hardware is present. And this basically means selecting some drivers that can drive whatever they have locally. And Genso will be shipped with a large library of drivers to help this, covering all of the common radio amateur hardware. If there is something missing, if you have a particularly strange piece of kit, then we invite you to write a driver for it. We might even give you a beer for the privilege. And then this can be shared with the rest of the radio amateur community, and everyone can use your strange piece of kit. Then we have the hardware abstraction layer, which is a standardized set of commands that's talking to this driver layer to do all of the control. And this is the important piece that means that we can run the ground station server on any station we like. But the user also needs to tell the rest of Genso what the station can do. So there's a nice graphical user interface through which the user can say, okay, these are the frequencies I'm happy to use, I'm happy to transmit, or I'm not. This is how much space I can take, this is when I can be online, this is when I'm going to be offline. This will all be user configurable. Once the ground station server knows these details, it will pass them to the authentication server, which then distributes these details around the network, respecting your privacy, of course, so that everyone, all of the different nodes in the network, know when the ground station will be online and what it is capable of doing. And once this is known, then the ground station will also be retrieving lists of the spacecraft in Genso from the authentication server. It'll be specified from the authentication server, okay, we have this spacecraft on this frequency transmitting packet or CW, whatever. And once this list has been retrieved by the ground station server, then we can do some local scheduling. We know when the spacecraft will be coming up. If there are conflicts, we can choose how to resolve them in a fair and equitable manner. And if we want to have the MCCs booking anything, then this is also possible because we have all the information we need about the spacecraft. And the data flow itself, of course, what everybody here is interested in is to get the data themselves. So we have a local database that will store all of the space-link information that you're transferring for your own perusal. But that's not the point of Genso. In the end, it needs to go to the mission control clients. So, of course, we have it forwarded over there as well. And this, overall, is the structure of the ground station server. Now, we have an example here. This is a live example. The Surrey Space Centre, which you all know and have looked around and had tours, of course. They've very kindly set up a ground station for their own use, but they're allowing Genso to come in and play with it. And over the last few days, we've got the ground station server running on the Surrey Space Centre ground station. And unfortunately, we were just out of the schedule for showing a live pass, but it will happen later on, and we can perhaps see. We've been running the demo yesterday out in the corridor, and you've all come to talk to us about it. As you've seen, this is the timeline. This is the present over here, and these are the upcoming passes. So you can see here we have a pass schedule for AAUSat-2. We have an Iridium pass. This is just a test spacecraft that we use. And these are automatically scheduled. You can see that I haven't been doing anything. There's nobody in the ground station. It's the weekend. They're all at home enjoying themselves. But quite happily, it schedules these passes. And then we have over here, just so that we can see what's going on. We installed some webcams of the rotator. Oh. So we have the radio at the top here. On my screen, you can see the numbers properly. So we can see when it's tuning. And we have the rotator on the roof. Oh yeah, you can see the numbers now. So there's a rotator on the roof. In typical student style, of course, this is a webcam picture of a TV screen with a TV feed of a video camera from the roof. But it works. We can see when the antennas are rotating. And yes, so if I'm allowed to carry on long enough, then you'll be able to see this pass happen. But you all saw this yesterday anyway. So that's the ground station server, and at the moment, as you can see, it doesn't look too exciting. It hasn't got bells and whistles and flashing lights to the extent that we'd like, but this is just the alpha version. So we've got the guts of it working. We've developed it to the point when it does what it needs to do, and the final version, of course, will have nice graphical user interfaces and configuration screens, and but the core functionality is already there, and that's the important thing. Okay, so now I'd like to talk about the other side a little. Oops. So the mission control client, who's the user of that? Well, there'll be one mission control client per spacecraft. So we'd have one for AAUSat-2, we'd have one for Sci-4, one for Sci-5, etc. And the users are then the controllers of that spacecraft. Similar to the GSS, they configure the MCC to reflect their spacecraft details. So they will say what frequencies they're using, what their TLE is, when they are expected to transmit, and this information will be passed to the authentication server so that it can compile lists to give to the ground station server. As we saw in the last slide, the ground station server needs these lists so that it knows who to track and when. There's a local database again, of course, but this time, rather than storing all of the data from one ground station, this stores all the data from one mission. So from all over the world, different GSSs will be tracking the spacecraft and will submit the data to this mission control client. So if it's my mission control client, I can simply sit there and watch as data from all over the world comes automatically flooding in that doesn't require any radio amateurs anywhere to do anything apart from configure the software initially. That's for the downlink, but there's also a booking agent in the mission control client, and this is where it starts to get a little bit more clever. This is for the uplink that we're planning. And the idea there is that as a spacecraft controller, I might like to uplink to my spacecraft when it's not over my station. GENSO will allow me to do that. It will present me with a list of the potential future passes for the next day or so. The passes where I can book an active SpaceLink session. And if I choose to make a request, simple point and click, I would like that one please for 10 o'clock tomorrow morning, then the negotiation will happen by itself. I'll be informed as to whether or not this pass is booked. And when it comes up, it will happen in real time. And there will be a direct link between my mission control client and the appropriate ground station server, such that I can send telecommands from Papua New Guinea that are transmitted from Surrey Space Station, Space Center, and the received telemetry coming back down comes straight over to me. So it's just like I have my station with me. But we don't just want the data delivered to a human. Humans aren't very good at decoding hex very quickly, as I'm sure we've all experienced. So most spacecraft, of course, have some proprietary software. They have some kind of satellite application that's maybe showing levels in tanks and temperatures on PCBs and this kind of thing. And this is normally decoding the data coming off of their TNC. Well, we don't want to change all of that. We don't want the people that come to GENSO to have to do anything drastically different to what they're doing already. So on top of the MCC, we have what we call the wall plug, which is just a virtual port. It just behaves exactly as if it's the top end of a TNC, so that you can point your satellite application at this port instead of at your own ground station, and you'll just get all of the data you're going to get already and more. That's the idea behind the GENSO wall plug. It is to make it as easy as possible for anybody involved. We will also allow the proprietary software to control the MCC via an API. This means that you could automate the booking, that you could automate any configuration changes. If your spacecraft is changing mode regularly, then you don't want to tell GENSO that twice a week. You can set it up so that this is automatic. So that's an overview of the mission control client. And of course, in true style, we have one here. Now, this is what will be running for each mission control. Again, it doesn't have bells and whistles at the moment. It just is purely functional. This is on my local machine here, but this list here is a list of the part of the data that other ground stations have got for this mission control client. This one's actually configured for AO51. So these are the passes we've had for AO51 over the last couple of days from the Surrey Space Center. And this could be running anywhere, as I say, Papua New Guinea, not a problem. And it quite simply retrieves this list from the authentication server and then goes and gets the data directly. I could show you the data, but it's Huffman encoded audio, and I don't think that's particularly interesting for you to see in a presentation. That's the mission control client. that we're developing to make it look nice as well as doing what it does already. So just to show you how that fits into the grand scheme of things, this is the Genso functional block diagram. We can see the ground station server is all of this, which involves the Danish code at quite a high level for the ground station server, the booking and the negotiation with the MCCs and the database and the scheduling. We have the hardware abstraction layer with all the drivers, which is a collaboration between, again, the Danes and our Japanese friends. This is a global initiative. And over in Japan, UNISEC have developed a ground station network also. Of course, we don't want to compete. We're collaborating. So we're making sure that we can interface with this so that everybody can be part of the same party in the end. Of course, we have the authentication server and some infrastructure and the mission control client. And this is the functional block diagram that we use internally in Genso to keep track of what we're doing and make sure that everything connects together and makes sense. So where are we at the moment? I showed you what we've done as of workshop 5, where we had this proof of concept. But where are we right now? Well, we had workshop 6 in STEC in March this year. We have to say we're going a little bit slower than expected, but this is normal of almost any project you've heard about this weekend. We have some manpower issues, but they are in progress. We're hoping to solve them very soon and speed things up. But we also recently identified the need to re-engineer the project requirements somewhat, to really go back to basics and make sure that we had all of the requirements very, very clearly specified. So this necessitated taking a little bit of time out from the coding and the production of the software applications that I've told you about, and going back to basics and really figuring out exactly what it is we're trying to do and specifying it properly. And this is the requirements tool we're using. It's Truck, and it's pretty good. I can recommend to anyone that is working on a project where you need a decent requirements tree. Truck's a nice free tool. We are working at the moment on the alpha test, which is getting all the core downlink and abstraction functionality working properly. For the alpha test, we have maybe half a dozen stations, and we're tracking half a dozen spacecraft and making sure that everything works properly. Of course, it doesn't quite, which is the point of the test, to then find out the problems and fix them. And we're very, very close to closing this. We've also, I'm sure, to preempt potential questions from Arkim, where is he? Hi. We've also recently been re-engineering the data layers and formats that we're transferring back and forth to make sure that we're not just supporting AX25, we're covering all sorts of other possibilities as well, and very open to new protocols in the future. So right now, we have GSSs running at Aalborg, at Cal Poly in Kyoto, Graham, G3VZV, Dave, G4DPZ, the Surrey Space Centre here, and we have mission control clients registered for all of these spacecraft so that we can see how they're progressing. Although we don't own any of these spacecraft, of course, but we're just doing passive downlink at the moment, so it doesn't matter too much. And since we started playing with Genso, really, we can look in the authentication server and see how successful we've been. And at the moment, the authentication server has something like 2,500 pass reports in it. That means that spacecraft have been tracked over 2,500 times in Genso just in the last couple of months, with only a handful of stations. And this is where the automation is powerful. Because while we're all here talking and enjoying ourselves, the Surrey Space Centre is going to track these 3 spacecraft, and another ground station somewhere else will track another 3 spacecraft. And once you add all of this up over a longer time period, you get to a very large number of passes. really quite a significant contribution to these missions. What else can we do with it? Well, we've had quite a lot of questions about this in the demo that we had outside. People coming along saying, "Oh, have you thought?" Well, we have thought quite a lot, but one of the advantages of Genso is that it's open source. We're developing it under GPL, and we expect that once we've deployed the network, our users can develop their own plugins, their own drivers, their own bolt-ons and add-ons to make the network even more powerful. Some of the ideas that we've already thought of are to have the scheduling currently is done locally at each of the ground station servers, and this could be done a little bit more intelligently on the authentication server, and therefore tracking the quality of the passes and predicting which passes are going to be good and which are not, and having a much more sophisticated weighting for which is chosen if you have a conflict above. So this is one of the key things that we're looking at the moment, and Bastian is here somewhere, is working on that for us. We are quite open to the idea of software-defined radios and modems. On the functional block diagram I showed you before, you simply replace a driver for a piece of hardware with a software-defined modem or a software-defined radio. And this is no problem at all for us. We can potentially use multiple downlinks from the same spacecraft simultaneously for error correction, since we're not just doing it at packet level, we're also looking at audio level. We could have emergency overrides. This could be quite powerful. So if you have a spacecraft in trouble that says to Genso, "Oh, my battery volts are dropping. I would love to have uninterrupted coverage for the next half day or something." If people in the network are amenable to that, not at the cost of their own missions, of course. Many different locations, you can quite quickly determine an orbit, in theory, although the maths is going to be horrible and data mining is going to be rather interesting. But this could potentially be quicker than NORAD. So it would be very useful for these launches where you have a dozen CubeSats being spat out of a vehicle altogether. And there are various other possible gamma phase developments, and I'm sure you can come up with many, many more. That's the whole point. Things like inter-spacecraft communications, that we heard a presentation from SSTL about wireless links between spacecraft. With Genso, these spacecraft could talk to their own mission control clients, as I've already shown, through an arbitrary ground station to their own mission control client, and then you could have the satellite application above talking to multiple mission control clients, and therefore forwarding data between spacecraft from opposite sides of the planet, regardless of what ground stations they're using. You don't care. These spacecraft can talk to each other with Earth in the way. That could be quite an interesting development for constellations of satellites. So right now we do actually have a pass ongoing. So let me reload this. So you can see that the radios are tuning. That number just changed. These webcams are only refreshing every half dozen seconds, I'm afraid. But the radios are tuning and the antennas are rotating. At the moment we're tracking, what is it? See, I don't even know. It's wonderful. It just does it. We're tracking AAUSat 2. So good luck for us getting any data from that. But we're tracking AAUSat 2. Waiting for the next webcam update. It's doing it. The rotators are clearly not at the horizon, but the refresh rate is a little low right now. And then afterwards we have coming up as I say, a passive and Iridium spacecraft. But I must crack on with the presentation. We could look at the ground station doing stuff all day. So what are the benefits of amateur radio, of radio amateurs being involved? Well, For a start, in Genso, you get greater utilization of your ground station. You get much more. I should stop this from logging out. No, I can't, so never mind. You get greater utilization of your ground station, much more data from space, basically, which is what you're after in the end. It fits around your normal operation unintrusively. You don't have to change anything that you're doing. You're not locked out of your station because it's in automatic mode. You can always be involved. You can always take manual control at any time. Genso is set up so that you could run it just before you go to work, come back 8 hours later, and then log out and carry on with your own interest, with your own hobby in the way you enjoy. But in the meantime, it will have tracked 20 spacecraft. It would have helped 20 missions, so you can feel very good about yourself. Makes a very tangible contribution in that respect to these different projects. We'll maintain statistics. There's going to be a lovely website, we're sure, showing the status of Genso, which stations have got the most data, which stations are getting data at the moment, who's tracking who. So we expect quite a community to spring up around that, looking at what Genso is doing, and maybe a little bit of friendly competition as to who can contribute the most data to the network. Being an open source project, we expect we can find lots of interested people to come and work on some extra add-ons and plugins, as I say. So part of an exciting, growing open source project. And as you can see from the number of people here from a slightly different generation to a few years ago in the Colloquium when I first came, this is encouraging a new generation of radio amateurs. This is getting involved with the CubeSat community. This is getting involved with the ESA Education Office that's working with so many young people, and this is bringing new people to the hobby. And after all, in the end, it's great, powerful, free software. We all like that. And this is just how happy a radio ham can look when working with the ESA Education Office. So we have a lot of people asking us how we can get involved. Well, at the moment, as you can see, we're very busy on this alpha testing phase. We're very busy developing the software. So we need to hold on a little bit. But we will be entering a beta phase in the not very distant future. And then if you're interested to join as a development station, you can get in contact with us. But this will involve working with some half-finished product, of course. But we have quite a lot of interest we see from that. So we're looking forward to inviting some extra people to help us out on this project. And once Genso is operational, as I say, anybody can join us. That's the whole idea. This is a list of our current participants. It's not meant to be exhaustive. It's just showing. In fact, I haven't updated this for about a year, I think, because we just lost track of how many people want to be involved. So it's really going to be quite a large community once we're up and running. The project website is genso.org, and I should also just quickly introduce the Genso project manager now is Mrs. Helen Page. If you stick your hand up, this is Helen from the Education Office, who's come here today to see you all. So these are the contact details for the project. So does anyone have any questions?
Yes. A fairly simple question, it comes on from yesterday. With the advanced booking for your uplinks,
yep.
What sort of lead time do you have to give the system do you expect?
Good question. Well, it depends how popular you think the pass is going to be. If there's the system will notify the user of the mission control client for the whole of the next day or so. So you have 24 hours notice of which passes are available. And then, of course, everyone has that notice. So if there's lots of people trying to book, then you might want to get in early. But if a station is not busy, if a station is idle, then you can book the pass minutes beforehand. Really, immediately before the pass starts, this could be scheduled. No, at the end of your answer, can you repeat the question? Sorry? Could you repeat the question? Yes, the question was how long in advance would you need to make the booking for an active uplink? The answer is a couple of minutes, unless you're unlucky and it's very busy, in which case you need to be a bit earlier.
Yes. First of all, congratulations for your call sign.
Thank you.
I think that from a radio amateur point of view, if you want to have their strong interest, it would be nice if you allow them to interrupt the automaticity of the system and still use your system to know when they can do QSOs with their radio amateur frequencies. So your system would automatically identify the scheduled visibility passes over their station, but at some time, and it will be a small amount of the duty cycle of their ground station per day, you should allow them to, okay, interrupt. Now I play with my 5 minutes QSOs thanks to AO51, and then, okay, I finished with my pleasure, and I come back as a participant of your system. Did you consider this? Yes,
we have considered this. It's an excellent point. Genso will be, at any time you can take manual control of any of the individual pieces of hardware in your station. So you could log out of Genso and you'd be reverted to your normal situation where you can do whatever you like, or you could leave Genso tracking AO27, for example, and the idea is that we can add in the place of the TNC, we could be using the audio, and we can add drivers that allow a QSO through Genso. So Genso is doing all of the tracking, all of the Doppler correction, and you simply need to talk. This is foreseen, yes.
Okay, we've just time for one more question.
Ken?
If we have it over there.
Yes, Chris, actually.
Oh, sorry.
You're trying to get me to be rude. We've heard some of this before, and it sounds pretty good. In your, well, not necessarily your opinion, do you think it's do you think the project's going as well as it could do, as fast as it could do, should I say? Because I heard you say about going back to basics and rethinks about things. I don't want to put you on the spot, but
no. Thank you very much. It's not going quite as swiftly as we anticipated, but this is quite normal, really. Right. I think maybe as I say, we had a few manpower issues in the education office and on the student side. Perhaps Helen can say a few words. I'm not sure as the project manager. Sorry. It's ESA driven, yes. But we are ongoing. We're going as fast as is sensible. And the issues we are facing at the moment is, as I say, the student manpower. So we're actively looking for some new developers as well, which I think maybe we've made some inroads towards during this colloquium. There's a couple of interested parties have come up, and I haven't managed to speak to Helen about it yet. But we have some potential interest for getting some more students, which is nice. And from the side of the education office, Helen can tell you the plans, perhaps.
Okay, thanks very much for that. So we won't take any further questions just now, but if any of you have more questions for either Neil or Helen, then see them during the coffee break at 11 o'clock. I'd like to express our thanks now to Neil for